Hello everyone, we are Team 22 and we're going to be presenting the analysis and redesign of a gas grill assembly. Our team members are Ruth Roloff, Eric Klent, Jose Daniel Rivera, Emmanuel Terron, Griffin de la Heras, and Jorge Diaz Castro. For product introduction, we have the gas grill assembly, where the main usage of this is out of grilling. The market research, we estimate near 20 million grills being sold in the US per year, and we identified two types of customers. The primary customer, the Supreme line, for retail and wholesale stores, and this grill will contain the baseline feature. The secondary customer, the premium line, where the grill will come with the features that enhance the interaction with the user. For the expanded view of the product, we can identify the baseline items of the assembly having a total of 19 components. It's important to mention that for this analysis, bolts and nuts has been excluded, and we also considered burners and the tank as a black box being provided by a third-party supplier. At our fast diagram, we can identify the basic functions that are being taken in consideration for our two types of products, and the supporting functions, where we focus on the improvement to offer for the secondary customer that enhance grill experience by providing better control of temperature, improved transportation and handling of the grill within others. And here we have the function component mapping matrix, where we map all the components from the assembly and link to the basing and supporting functions mentioned on the fast diagram. As we can see here, this way we can identify the components that enable the main functions of the grill, and the other items are related to support and enhance features of the assembly.
As you can see here, we have our functional differentiation table and component commonality table. On the left is the functional differentiation table showing the similar and different functions between the primary and secondary customer product lines. And on the right there is the component commonality table showing the different platforms and modules. So here we have the product family design. These are the different CAD models for the primary and secondary customers. On the left shows the primary customer product line, and the right shows the secondary customer product line. The differences in the products from the functional differentiation table are shown with the red arrows on the right there. And here's some common interfaces and module differences between the two product lines. The top shows the primary customer line, and the bottom shows the secondary customer line. And the red arrows indicate the common interfaces between them. So here are our assembly sequence. The top shows the original assembly sequence, and the bottom shows the improved assembly sequence for the two product lines. And for our manual design for assembly analysis, we use the quad chart, and the high cost and high functional importance components were up for redesign, so we selected a platform and a module from that category.
Then if we continue with part selection, we will see that side table, plank wood, and the brace corner upper are one of the components with major assembly time, one with 54 seconds and the other with 30 seconds, mainly because the quantity of parts 7 and 4 for an assembly efficiency of 5%. Then we can apply the DFI to redesign the part. There are some principles like reduce the part count from 7 to 1, reduce the fastener from 14 to 4, increase the part symmetry, add some new ribs, new features for ease of insertion, and well, new features to absorb variation included in the same part. Then if we do the functional analysis, we will see that the side table plank wood is related with the function of support material and assist cleaning, and the brace corner lower component is related to support the cover. Then what are the critical dimensions to keep the function of the part? In that case, for the module, we can say that the critical dimensions ensure the adequate support and rigidity for cooking supplies, and also the ease of cleaning through a decrease in incoming gaps. So the quality surface is enough to have only a 0.3 millimeters of tolerance, and something similar for the position of all the holes. The process selection for part 1 consider a 3D solid shape, a mass of 0.48 kilograms, a section of 7 millimeters, the tolerance of 0.3 millimeters, the surface about 1, and the production volume over 1 million. So the preferred process is the injection molding. Starting with the DfM, We consider a flat parting surface, a dual core tooling, tolerance of 0.3, surface finish of 1 mil, the volume over 100 centimeter cubics, wall thickness of 7, and the NSP 37 surfaces. The material cost was $5.5, mold cost only $0.024 because the volume, operator cost of $1.6 for a total of $7.2. We found a lot of improvements in DfM Pro, like minimum radius at the base of the boss, the minimum radius on the tip of the boss, some minimum draft angle, uniform wall thickness, and also, well, the mold wall thickness. The redesign of the part consists to minimize the wall thickness from 7 to 2.7 millimeters, keep the minimum wall thickness, up some missing draft angles, and well, avoid some sharp corners, and also will keep the rib thickness under the estimated. So then we have a volume reduction to around 500 centimeters cubics for a material cost of $2.3, a mold cost of $0.04, and operator cost of $0.34 for a total cost per part of $2.7. Finally, as a comparison of the before part design and after part design, we can say that we have a reduction of $4.5.
It was the platform support subassembly. We reduced the part count from 22 to 9 and fasteners from 16 to 8, while not impacting the function at all and making orientation easier. For the old platform subassembly, handling costs were 4.758 cents per part. Insertion costs were 26.64 cents per part, for a total cost of 31.398 cents per part. Now with the new platform subassembly, we've decreased the handling cost by 64%, decreased the insertion cost by 50%, for a total cost per part decrease of 52%.
When redesigning our parts, it was important to take note of our critical dimension. Our critical dimension for our redesign was the hole locations and sizes, highlighted in the red boxes, and these were determined to be the critical dimensions due to the fact that they ensure rigid support for the lower grill cover by allowing for efficient mounting to the support legs. Additionally, with our new part, we needed to look into process selection. Using the chart on the right, we were able to determine that sheet metal working was going to be the best process for our new redesign. And we are going to use a low precision with our tolerancing being only about 10% of part thickness. For DfM Pro, we did do a before and after. So putting in our original part, we can see that it did have some issues with the bend radius to thickness ratio and would want us to increase our bend radius just a little bit. And we were also able to determine that the total cost per part is going to be about $4.66. Looking at our redesign, we can see that the overall size does get a little bit bigger. The width remains the same, but the length does increase quite a bit. And we can see that our new quote analytically will be about $3.03 per part, and the hubs quote will be about $3.76 per part, of course, meaning that our improvement has saved money.
For a product sharing system, the goal is to improve the customer experience and lower costs by adding a subscription model where customers pay a monthly fee instead of upfront cost, online cooking to provide recipes and cooking techniques, extended maintenance to provide regular maintenance and repair services, and we also reduce the negative impact on the environment by adding energy efficiency and end-of-life recycling. In summary, for DFA in the manual assembly, we reduced 12.6 seconds and 13.35 seconds on the side table and the brace corners. For the automatic assembly, we saved 16 cents, and for the side table manufacturing, we saved $4.5. In the brace corners are eliminated, we reduced $7.24. The critique on the project is DFA needed for other high assembly time components and DFM needed for other not selected parts.